Related rates problem number 13 uses an angular velocity, and I thought that might catch some of you students out there. It certainly is hard for me to picture, so I thought we'd go through it. The problem says there's a lighthouse, which I'm going to make a little dot for my lighthouse. And it says that the nearest point P, which I'm going to put here, call it P if you want, is 3 kilometers away. So let's make a 3 here. And it says that the beam of light makes 4 revolutions per minute on this lighthouse. So let's just draw a little kind of thing here. And we'll write out the data for it. The angular velocity is 4 revolutions per minute. And I don't like revolutions per minute, so I'm going to times this by 2 pi to get the angle itself. I'm going to get 8 pi radians per minute, like that. Okay, what else do we know? We want to know when the beam is like over here, some x distance away. Now they're going to tell you they want it for when it's 1 kilometer away. But what that means is, because your angle is changing, you want to find the general function, and then we'll plug 1 in for x after we find our derivatives and stuff like that. So what do we know? Well, our angle obviously is here, because we're talking about the lighthouse. I don't know if you remember your SOHCAHTOA, but you're going to wish you did for this problem, like this. Okay, now what? Well, what do we know? We know opposite and we know adjacent. That's tangent. So I can say tangent of theta is equal to x over 3. In other words, x equals 3 tan theta, whatever theta may be. Maybe we'll need it, maybe we won't. And the first thing I want to do now is find this derivative, because they're asking for how fast the beam of light is moving. That would be the derivative of the distance in this direction. So dx dt equals 3 secant squared theta. D theta dt. Don't miss your chain rule. That's how I make mistakes here. D theta dt. Very important. And I like this so far. So this is what we're looking for. We just have to figure out what this stuff is. Well, we know d theta dt because we just solved it. It's 8 pi radians per minute. So we'll use that. And then what else do we know? Well, we know the tangent part. I don't know the secant squared part. So maybe we can convert it, because we know that secant squared is equal to 1 plus tangent squared. I think that's the identity. I can never remember off the top of my head. But that means we can convert this. And we know tangent, because it's right here. Right? We know that x value, what do they want? It's 1 kilometer from P. So we can plug in x now that we have the derivative equation. We'll say it's 1. So I know that tan theta equals 1/3. Opposite over adjacent. So tangent squared, that's going to be 1/9. So secant squared is going to be 1 plus 1/9. So I'm going to say 3 times 10/9 times 8 pi. And now it's all numbers. Yeah? So 3 times 10 times 8. Well, 8 times 3 is 24. So times 10 would be 240 pi. Come on, hot computer. 240 times pi. Do I have a pi button on here? And then divide by 9. I got 83.776 for my dx dt. That's pretty fast. That beam is moving pretty fast, but that makes sense because it does a full circle every 15 seconds when you're a kilometer away. So that would be the number of kilometers per minute that we've been calculating, wouldn't it? That's pretty wild. That's a lot faster than I would expect. But you know something? You got to work it out. And in terms of angular velocity, don't get tripped up. Make sure that you do radians per whatever. Not revolutions. Radians, that's your angle. And then look at the triangle and figure out, is it a cosine, is it a tangent? But you notice I didn't find the angle. I never found the angle. You don't need to know the angle to do this. You need to know your trig identity, and you need to know how to build your tangent function, and you need to know how to take your derivative of the general function, which means up here, don't make it 1 until you have your x in there, and you find a formula for anywhere on the shore. I could make x 50, I could make it negative 50, and this will still tell me if the beam is this way, how fast it's moving. I can still do that if it's just x. And we solved it that way. So get to this answer. Give it a couple practice shots. It took me a couple tries to make sure I had this right.